So we put out a few videos now of our robot here, Antwerp, the project that kind of got all this started for us to bring the Robby framework into existence. And we thought we'd spend some time kind of showing all the pieces of Antwerp and what's inside of it and how it's all put together. We're going to kind of start at the top on the outside and dig our way down and open up the panels and take a look inside at what's going on there. So at the very top here, this is an Intel D435i depth camera. So it can tell you the distance to every pixel in an image and also do a lot of other things, including IMU functionality, accelerometers, all kinds of stuff going on it. Then next to that, we've got an RP LiDAR. I think it's a R100 or something like that. I think it's an A1M1. So this is a 360-degree LiDAR sensor. At some point, we'll probably do a video on this, how it works, and show you the output that we get from it. We use it for collision avoidance and just general distancing to things around us in a room. We've also gotten started on using it for SLAM. So yeah, we've done some work with MATLAB, getting ready to do SLAM navigation with this, which we're making a lot of good progress on. We're not there yet. We haven't got the version of MATLAB we need to really do it right yet. But we're going to be getting that soon. Everything's run, including the Robby framework that controls everything on the robot, is run by this Microsoft Surface tablet. Then coming down, staying on the outside for now. This is an arm we got from a company called Trosson Robotics. I believe they're somewhere in Illinois around Chicago. It's about a 3-year-old arm, so they don't even support it anymore. They've moved on to bigger and better arms, but this one still works well, and we've been pretty happy with it by and large. Then moving down, you've got the inside of the robot, which we're going to open up and look at in detail. This is the speaker, so the robot can talk back to us and play music and that kind of stuff. Someday it might be a little bit like Alexa or one of those things, although it's not there at all yet. Then you can see around it there's these 6 little boxes, only 4 of which are being used right now. But these are ultrasonic range sensors that we use for collision avoidance, for seeing things down low that we might be getting close to and need to avoid or stop and to avoid a collision with them. So that's kind of the outer part. These treads here, tracks, actually move the robot. I think in our other videos you can see those working certainly. So now let's kind of start at the top and open things up and have a look and see some of what's inside of it. So first we're going to unhook the tablet here, and we're going to take off this panel on the front here so we can see inside what's inside here. Okay, so I usually call this the upper sensor compartment, but that's just because I needed to call it something. Obviously, the big thing going on here is the battery. This is a 30 amp hour, 12 volt battery. It's lithium iron phosphate. So that's going on. This battery I think was designed to be used in the little scooters that people are disabled use to drive around with. This powers those. Ends up being a really good power supply for the robot, because the robot can put out quite a bit of load, especially off the tracks. So this can go up to a 20 amp output and stay there for quite a while. So aside from the battery, up here we have one of 4 Arduinos that's in the thing. This is an Arduino Mega. Right now it really has two main functions. One is it controls the pan and tilt servos for the main camera, for the Intel camera at the top. But then also down here, you can see we have a digital compass that's set up. It's enclosed in that plastic there to try and minimize magnetic interference with it. And the Arduino here is also controlling that and getting the data that comes off it. Then the other thing we have down here is just a hookup. This is a UART converter to make it so we can do UART with the serial port used to run the LiDAR sensor. And then of course this I call the holy cow, turn it off button. This is a tip if you're ever going to do a robot like this, you always want a really easy thing to get to just shut it all down. And this does that. I can hit this button and all power cuts off immediately. That's something I didn't understand about robots till I got into this project. First time I ran it into a wall and broke something, it was like, okay, I need to be able to shut it off really easily. So anyway, moving along here, we're going to come over here now to this side panel here. And before I remove it, you can see it's got ultrasonic sensor here to see. We use the sensors on the sides for when we're doing collision avoidance. When we come to a wall or something and we stop, then we want to see which side has the most room and turn towards that side to get away from the collision problem and start moving again. The other little thing here is this jack coming out the side of it. This powers the battery, so I've got a charger that I can just plug into that to charge up the battery and keep everything going that way. So we're going to go ahead and remove this panel because I want to show you some things going on inside of here. So two pieces going on here that I want to look at. These are all part of the power system. First off, power comes from the battery. The straight 20 amp full load power comes to this. It's called a buck converter here. And this we use basically just to kind of condition the power and make sure it's a steady amperage. And make sure that everything's kind of, batteries will go up and down in the voltage they really put out, and the buck converter just kind of cleans up that power and makes it better for using with the robot. It also provides some protection for the battery, although the battery has built-in overload protections or short circuit protections. But it kind of enhances that and ensures that if we're going to blow something up, burn something up, which I have done. We have failed the smoke test with this robot before. The buck converter makes it so the $12 buck converter will fry before the $200 battery fries. Then the other thing I just wanted to look at here real quickly is this power panel here. So we're going to look at the power panel on the back that does the power distribution. There's about 6 different circuits on the robot that all have to be powered individually. But they're all limited to 6 amps. But the motor drivers need to be limited to 20 amps. So this splits that power, takes some power, or takes the power and runs it at the full 20 amps coming off the buck converter to run to these 2 motor driver cards here. These are 20 amp motor driver cards mounted on another Arduino. The robot actually includes 4 different Arduino Megas. I used Megas because I hadn't really played with Arduinos before and it seemed like more has got to be better. Others would have been fine though, but we've gotten Megas. These are called Mega motor drivers. They're 20 amp motor drivers. I had kind of a hard time finding them. But they work really well, and they're hooked straight out to the motors, and they're getting the power straight off of the buck converter. So that's most of what I wanted to look at here. Actually, while we're down in here you can see kind of down here, and let me turn here a little bit. Everything in this thing runs off of this 10-port USB hub here. This is a powered USB hub. So it uses a 12-volt line into it, and there's so much stuff that's running off of this. The LiDAR runs off it, the cameras run off it. All of these things are taking power off it, so you need a powered USB hub for an application like this. And this one here is 12 volt. You can get 5-volt powered hubs and 12-volt powered hubs. We went with 12 volt so that we can really maximize the power that we can run through the thing. Okay, so that's what's on that side of the robot. Now let's spin it around here and let's have a look at what's behind this panel. This is the left-hand panel here now. You can see we've got the other side sensor. Now inside of here, I'm not sure how good you can see it in there. There's another Arduino Mega here, and this one operates the ultrasonic sensors. Now when I first did this, I only had one Arduino Mega in there. And it was actually trying to do operating the motor drivers and the sensors simultaneously. And that's when I had a hard lesson about the single-threaded nature of an Arduino card. Because that loop on the Arduino card is the only thread in there, and anything that interrupts that loop, interrupts anything that's running on the card. So my sensors would work fine unless I happen to be giving a command to the motor drivers at the same time as I needed to be using the sensors, like telling it to stop when I'm about to hit a wall or something. And it was causing real problems. So that was a big lesson for me, and where I learned that there was really no reason to have Arduino Megas, because you're only going to put a little bit on each one anyway. The sketch is only going to run one or two very simple things, typically, because of this issue. You really can only get away with that. All these wires here are just hooking up to the 6 different ultrasonic sensors. Each one goes to an analog pin, and then has a digital pin also, and those are all brought together into this block so that we can then break them out to these ribbon cables that go out to the actual sensors. This right here is a 3 terabyte SSD drive that we use for when we're doing data collection. All of these sensors, we can log all of the data that comes into them, and with some things like the camera and the LiDAR, we're getting a fair amount of data in there. So I didn't want us to run into data storage problems. So we've got 3 terabytes of space here that we can put things on. Okay, so that's what we've got on the left-hand panel here. Put that back on. So now this is kind of my favorite when we're going to look in the back here. And this is where the power distribution system is set up. It's kind of a pain to unhook these ribbon cables for the sensors. Okay, so this is what we call the power distribution network here. It's kind of a highfalutin name for it, but that's what it does. This is the 4th Arduino that's on the robot. This is another Mega here that's running. This is what's called a T800 power shield, which I got from the robot shop. It's a real handy thing. This allows for breaking a 12-volt power supply up into 6 different individual supplies, and each one can have up to 6 amp output on it. The nice thing about it is I can turn these on and off programmatically using serial commands. So it's real nice if I want to turn the arm off because I don't want to waste the power to run it right now, I can do that. I just have real good control over which of the circuits are running. Basically what happens, the power comes off the buck converter up here and comes down into here, and then it breaks that off through this board here, and these are the grounds that come back to it. That breaks it up to where each of these jacks here has a 12-volt power supply that I can turn on and off programmatically from the tablet. And then this is all just stuff I did with the 3D printer here to make this nice little panel to plug in and out of. It makes it all real handy to be able to just turn these on and off when I need to for any reason. On my UI for the MCP program that runs this under the Robby framework, it's touchscreen, and I can just turn each power circuit on and off real easily. This right here is actually just a car cigarette lighter charger that makes it so I can charge up the notebook using the battery also, or the tablet can be charged all the time too. My goal on this was to have one source of power that powers everything. Powers the arm, powers the tablet. Everything gets powered through the battery, through a single circuit, and then it all gets charged the same way. I can just plug the jack in, and I can be charging up the tablet. I can be charging everything on the robot that might need to be charged through one jack, and then one line comes off that comes back to here. So it keeps it all pretty simple. So that's pretty much the internals of the Antwerp robot. We've been working on this, or mostly I've been working on it, I guess, for the last close to 4 years now. I'm a little bit embarrassed to say, but it has been a labor of love. Anyway, thanks a lot for watching. If you like this video, we encourage you to click like, and we'd love for you to join our We Are Robby YouTube channel. Thanks very much, and we'll see you next time.